MacBook Pro. This is a 16 inches. It says that it's dead. For some reason, it said that the device has been here before. So yeah, I need to understand. Okay, so first thing first, we are going to take out the back screws. Okay, back screws are out, back lights out. Wait, is that okay? Okay, so hmm, the device looks like a liquid damage. It looks like it's been exposed to some kind of oxidation. See, that cap doesn't look okay. That cap there doesn't look okay. Okay, but yeah, let's take disconnect the battery and get to understand what's happening. First and first, we want to check to see if we have a short on our PP bus well. Oh yeah, this is a 16 inches. I don't know if I mentioned that. It's a E2141, and the board number is going to be 80-01700. So we are going to have our black probe on ground and then a red probe on PP bus. We don't have a short on PP bus. Okay, that's a good thing. But then this guy here, this cap here is not looking good. We want to see what that cap is, and let's open up the board view. And by the way, even though that cap was looking good, so usually with the 16 inches is after you have measured for PP bus, a short on PP bus, the next thing I would do is I want to check to see if I have a short on these two guys here, because that's a 2.5 volt. That's a 2.5 volt rail. And then the reason why I that is of a concern to me, it's because of the positions of the cap by the edges of the board. So usually when you have caps on the edges of the board, there's exposure, and then that results in oxidation, and that results in corrosion, and then obviously the cap gets to fail. So we want to see if we have a short on our 2.5 volt line because of this cap. That cap is not looking good. So let's see. We have a red probe on ground and a black probe. What do we see? And that's a short. That's a dead short. And then on the other side, that's supposed to be ground. That's yeah. So we have a short there. So one thing we can do is we can just simply do that. Just pop the cap out like that. Cap is popped off, the one that's not looking okay, and then we check again. And that's it. We don't have a short no more. Okay, so that can just be the fix. Yeah, we don't have a short on pupils either. So let's just let's connect power to the board now, and let's see. Does our fan start? Nothing as yet. Okay, let's see. What do we have on PP bus? Let's hope that we have 12.6 on PP bus. 1.2. Interesting. Okay. Okay. Let's connect. Wait. Okay. Before that, we did check for a short on PP bus, and it says we didn't have a short on PP bus. So we only had a short on a 2.5 volt bell. Let's see. What do we? Okay, we still don't have a short. Okay, now let's connect charger and see what we have. Voltage mode. Let's see what we have on PP bus. 1.3. Okay, interesting. Um, so what I want to see is what do we have on PPDCN? Do we have 5 volt or do we have 20 volt? Let's say obviously we're not gonna get 20 volt because if we have 5 volt, okay, yeah, we wait, okay, wait. Let's not get it confused. Let's see what we have on PPDCN. PPDCN is 20 volt. Okay, and now it's starting. Maybe we'll have a problem with that port. It's a possibility. And that's okay. That's standard because we had an issue on the on the 2.5 volt rail for the NAND. That's okay. So we're just gonna click on enter. Um, and that's the fix. A short on 2.5 volt line. Okay, so that's beautiful, but we are not going to leave it at that. We are going to replace that cap, and then at the same time we are going to take the board out completely of the shell and see if any other cap, though has not failed now, might fail in future. So let's we don't necessarily need to see complete booting, so let's shut it off. Put it back on, hold the Alt key just to confirm that the device is working. By the way, the BME cable is not connected. That's the battery secondary cable is not connected. So, but I am using a 96 watts charger, which is rated for the 16 inches Intel. Okay, so there you go. Yeah, so device powers on. The primary problem we had was C9580, C9589 was our primary problem. That has been sorted out. However, we want to take the board out just to be sure that nothing else is an issue. So let's quickly do that. We're going to start with our T5 this time, T4 this time. Okay, T5 screws, T4 screws are almost up. Okay, now T5. Okay, now T8. That's it. We're now going to disconnect the cables. Okay, it's time to take the board out of the shell, docked and docked, making sure that no resistance from the cables. If there is any, you want to manually take that out of the way. You don't want to break any of the cables. Take your time, you don't have to rush it. Okay, that's it. The first thing we want to do is to make sure that we clean the sides. It's not good for the machine, especially the caps. When you're doing this, be careful not to rip out any of the cables with your whatever you're using. See that on the mic oxidation. Okay, let's put that on the side. Now to the board. That we're gonna replace. And then let's see what's happening on the other side. Let's turn the board on the other side. So need to clean that off. Clean off oxidation because we do not want the board to corrode from that section of the board. And on this side, remember this side wasn't working, so we are going to replace those as well. Okay, get another board first. Okay, that's about that. And on the other side, let's replace the cap that failed. Now we have to be careful not to hit the NAND chip. Okay. Okay, that's in its place. Then let's see what we have this side. That guy is not looking good. I think it would be best to replace it now before it fails. So most of the repairs we are going to do, the issue itself has already been addressed, are going to be preventive measures. Okay, let's see what else do we have on the board that needs to be addressed. Hmm, okay, I think that's about it. Okay, now clean the board again one time. Okay, on this other side here. Okay, that's about it. We're just going to test the board again. We know on this side of the board we didn't have anything, so let's see if that has changed now. Still the same thing. So okay, second port, nothing. When you flip it, nothing. Okay, let's check on the other side of the board. Okay, so we don't have uh, okay, so let's see why it is. So this side of the board works, but this side of the board isn't. But before that, let's see, do we have any funny thing going on? Because yes, we know that CD3215 was looking a bit. Oh, but by the way, this one's the CDs are CD3217s, not 15. Okay, so let's see what's happening on that side. We have a 5 volt or 0 volt. 0 volt on that, and that side. Right, and that side is what? 0 volt. Okay, and then the other one. Okay, we actually have 20 volt on one. Uh, see, we have 20 volt, and then we have 20 volt. So one port, and then the other port. What do we have? So one of the port, one of the port is not working. The other one does work. Okay, so that's fine. We're just going to reflow both CD3217 and okay. Just the board, Michelle. Did Voscom come to fix his device? The screen bezel. I should mention things like that so that at least I'm aware. We have trackpad feedback. Should have an Apple logo any moment from now. That's it. It's a beautiful Apple logo. Okay, so a bit of a recap. We don't want the device to boot to desktop, so we're just holding on the. Okay, yeah. So a bit of a recap. So on this one, what we had was a problem on C95. C95 89 was our issue. That was causing the short on the 2.5 line for the NAND. We popped that out, we did replace that, and immediately our issue was resolved. However, we had to take the board out to do some kind of a preventive repair on the board, just to prevent the board from fading in future, even though those issues were not directly related to the issue of the machine that we have. But as you guys can see, the device is ready. We are going to put it, uh, this particular one, the companies, they assemble the device themselves, so we are not going to assemble it for them. They usually do their own assembly for themselves. Okay, that's about it. Thank you guys. I'll see you guys in the next one.